The integers monadic verb. A rank 1 monadic verb that returns an ordered array of integers reshaped in various ways. But what exactly does this mean? Monadic verbs have one argument, always to their right. Rank 1 verbs operate on their arguments by breaking them down into rank 1 arrays, also known as lists, before processing them and reassembling the results. Integers is a verb that specifically creates ordered arrays of integers depending on the argument that it is given. But how does it do this? Well, it begins by assuming that we'll have a list of integers beginning with 0 and extending as long as required, and then uses the argument that is given to reshape this list into the resulting array. Of course, in order to reshape the integer list, only integer arguments can be used for the integers verb. Let's take a look at a few examples. Beginning with the simplest, an argument that is an atom, in this case, the integer 4. The integers that will be required are 0 through 3, and the argument is used to reshape the result into a list of 4 atoms. This is the most common way to create lists of integers for other verbs to use as their arguments. Moving up to the next level, we look at an argument that is a list of 2 integers, 2 and 3. Now the required integer pool will be from 0 to 5. And this is reshaped into 2 rows with 3 atoms per row. Next up, we look at the results of an argument of 2, 3, 2. This will require integers from 0 to 11 to supply the contents of the resulting array. And the reshaping will create an array with 2 tables consisting of 3 rows per table and 2 atoms per row. This covers the most common use of the integers verb within J. The next examples show the way that negative values affect the function of the integers verb. Starting with 4 as an argument, it is easiest to begin as we would with 4 and reshape the integers 0, 1, 2, 3. The negative value indicates a reversal of the integers so that the increasing sequence 0, 1, 2, 3 becomes a decreasing sequence. When we look at arguments of 2 integers, we can see the effect that having one negative has on the outcome. Here we need 0 through 7 as our integer list. Then we reshape according to 2, 4, creating 2 rows of 4 atoms per row, but taking note of the negative value for 4. And finally, we reverse along the axis of the negative value so that in this case, the 4 atoms in each row are reversed. If both of the integers in the argument are negative, then things play out pretty much as you would expect. We begin with the integers 0 to 7 and then reshape as we would for 2 and 4, noting the negative values. Then we reverse the results across their respective axes. For the purposes of illustration, we began with reversing the atoms in the rows, and then the rows themselves, but there's no need to do any particular precedence of reversal as long as the result is correct. In these examples, we will see how 0 values in the argument affect the results that the integers verb returns, beginning with the simple 0 argument. We go through the same process as we did with previous arguments with the integers required. When we reshape, we get 0 atoms, and that is represented by an empty row, which J shows as a blank line. Next up, we look at what happens when we have an argument of 0, 0. As you would expect, we're going to take the necessary number of integers, which is none. Then when we reshape according to the argument 0, 0, we end up with 0 rows of 0 atoms per row. Well, the only way to show 0 rows is to show no line at all. In J, this is one of the ways that we can return nothing as the result of an operation. Moving on to an argument of 2, 0, we once again start with integers, although no integers are required because of the 0 in the argument. Then we reshape them according to the 2, 0 argument, giving 2 rows of 0 atoms per row. And this is shown as 2 blank lines in the J interactive environment. If we reverse those 2 numbers to create an argument of 0, 2, we are back in the situation that we found ourselves with 0, 0. The integers are reshaped to 0 rows of 2 atoms, and with no rows, the result is no lines at all. Moving up to 3 integer lists, we go through the same process. Starting with 2, 0, 2, when we reshape, we get 2 tables with 0 rows in each table and 2 atoms in each row. Once again, the only way to show 0 rows is to show nothing at all, and we just move down a line ready for the next J sentence to be entered. And if we use list 0, 2, 2 as an argument, we can end up with a reshape of 0 tables with 2 rows per table and 2 atoms per row. But because we have no tables, no lines are returned at all. Finally, if we use the argument 2, 2, 0, then when we reshape, we end up with 2 tables and 2 rows per table and 0 atoms per row. Here we actually do have empty rows that we can replace with blank lines. And on top of that, we have to account for the space to show the 2 distinct tables as well. So in J, it is wise to be alert to the spacing of results when using 0 values in the argument list of the monadic integers verb. When we began this exploration, we'd said that the monadic verb integers is a rank 1 verb, and this means that it acts independently on each rank 1 component of its argument before returning the result. But up until now, we've only dealt with rank 1 arguments. Let's look at the simplest example of having 2 identical rank 1 arguments. In this case, they both have the value of 2, 2. We take each rank list on its own, first getting the integers 0, 1, 2, 3, and then reshaping them into an array with 2 rows and 2 atoms per row. When we've done this with both of the rank 1 arguments, the result is 2 tables, each one with 2 rows and 2 atoms per row. Pretty neat, huh? That's what it means to be a rank 1 verb. But what if the 2 rank 1 arguments are not the same? In this case, we go through the same process of reshaping the integers according to their rank 1 arguments, except that this time you can see that the first argument only reshapes the integers 0, 1, 2, 3 into 2 rows and 2 atoms per row, while the second argument reshapes the integers 0, 1, 2, 3, 4, 5 into 2 rows of 3 atoms per row. Because the 2 tables that are produced are required to match shapes, a fill of zeros is used to pad the top table to match the shape of the lower one. And we can get a bit more complicated than that when none of the values of the rank 1 arguments match each other. And just to top it off, let's throw in a negative value as well. So for the first rank 1 argument, we reshape the integers 0, 1, 2 into 3 rows with 1 atom per row. Then the negative value on the 3 reverses the rows. Note that the result in this case includes a value of 0 that is not a fill. The next step is to reshape the integers 0, 1, 2, 3, 4, 5 into an array of 2 rows with 3 atoms per row. Now, in order to match the shapes of the top and the bottom tables, we have to pad out 2 columns of zeros onto the shape 3, 1 result and add a row of zeros onto the shape 2, 3 result on the bottom. Integers is a rank 1 monadic verb that returns an ordered array of integers reshaped in various ways. Hopefully, these examples have given you a better understanding of how integers works.